Hello everybody, this is Vasvi from At Home Tuition. Today's topic is probability. So we are going to discuss about probability. So what is probability? Probability is the likelihood of something happening in future. That is, to be more clear, I can say the probability is a possibility or a chance of an event to happen, okay? So the happening of event, the possibility, the number of possibilities an event could happen is what we call it as probability. And also remember that the probability ranges from 0 to 1. It should be somewhere, the probability would be somewhere between 0 and 1, because probability 1 denotes a certain event, okay? That is, the event will definitely happen, and probability 0 indicates that the event can never be happen, so you call it impossible event, and all the rest comes in between this. Either it is impossible or sure event, and everything will be in between this. So the probability you can express in terms of fractions or a decimal. I told you, since it is between 0 and 1, it is a non-negative number. Remember, it is a non-negative number, and since it is between 0 and 1, it ought to be a decimal, or you can represent it as fraction or a percentage. You have three different approaches in probability. One is statistical or empirical approach. The second one is classical approach, and the third one is axiomatic approach. Okay, in the statistical approach, what we do is, you would have done it in the lower grade, like getting the data, collecting the data, organizing. Few examples like frequency table, bar graphs, and all that. And for the classical approach is what we are mainly concerned about now. So we are doing the classical approach right now, and the axiomatic approach is about set theory. That maybe we do it in the higher grade. So right now we are going to concentrate on this. Now, how do we find the probability of an event? So the probability of event, you denote it as P of E, is equal to number of favorable outcomes divided by total number of possible outcomes. Okay, number of favorable outcomes, I mean, see, when you do an experiment, you have too many options, right? Too many outcomes you can arrive at. So when you look into one outcome, you take the possibilities of getting that outcome, you put it as the numerator, and the total number of possible outcomes you take it as denominator, and that is how the probability is calculated. And one assumption we make here in this classical approach is the outcomes of an experiment are equally likely. Say for instance, if you are tossing a coin, okay, when you toss a coin, you have two options. You may get the head or a tail, right? So the total outcome here is 2, out of which getting a head will be 1, right? So that is 1 over 2, and getting a tail here is also 1 over 2. So you see that both has equal possibility. They are equally likely, okay? Both can happen. The number of ways by which you can get these answers are same. Got it? Likewise, say for instance a die, okay? When you toss a die, you can have the total number of outcomes will be like 1, it can be 2, 3, 4, 5, 6. Okay, you have 6 outcomes there, and getting 1 out of the 6 is 1 by 6, right? Chances. And getting a 2 on this 6 total 6 outcomes, the number of favorable outcome is 1, and the total outcome is 6, right? So you find that every number, every outcome is equally likely. All have equal number of chances. Understood? So that is what we mean by the events, the experiments are equally likely. Okay? When you add up these, I gave you 2 examples, right? So this is example 1, and here I have given you example 2. When you add up all the possibilities, okay, all the outcomes, it sums up to 1. You just see, you add all this, you get 6 over 6, right? So that is 1 whole. Got it? So this is 1 whole, and here too when you add these two, the total is 1, right? Half plus half is 1. So the sum of probabilities of all the elementary events of an experiment is 1. Okay? Please note this. Else you have gone wrong somewhere. And the assumption is that the experiments are equally likely. Okay? Now I'll just tell you the basic terms we use in probability. The complementary events. Okay? So what are complementary events? Let's take the example tossing a coin. As I told you, you either get head or tail, right? And they have equal chances, like half and half. Now I can call these as complementary events. I'll tell you how. If I ask you what is the probability of getting a head, we would say the formula I told you, the favorable outcome is 1, right? Head is 1 and the total outcome is head and tail, so that's 2. So it is half. Now if I ask you what is the probability of getting not a head, okay? The total number of the total is 1, right? The sum of the probability of all would be 1, right? From that you take away 2 and that is 2, 1 by 2, okay? So these two are complementary events. For impossible event, just see probability of getting a 7 when a die is rolled. This is definitely impossible, right? Because when you roll a die, you have the possibility of getting an event would be either 1, 2, 3, 4, 5, 6 or 5 or 6, right? So it should be somewhere between 1 to 6. You can never get something more than 6, right? So getting a number more than 6 when a die is rolled is impossible event. Understood? So it means there is no chance of that event to occur. The next one is certain event. Say for instance, if today is Tuesday, the probability of getting Wednesday tomorrow is sure, because after Tuesday it is Wednesday only. So that is for sure. You're going to definitely have that event. So that you call it a certain event. Okay? I hope you understood what is a certain event is, right? So we know what is complementary event, impossible event, certain event. And the next one is equally likely event. For this we can give any number of example, like you have many examples. Say for instance, tossing a coin, getting a head and a tail has got equal chances, right? So that can be an example. Or maybe throwing a die, okay? So getting a number from 1 to 6, they are equally likely events, right? Any number you can get any. Or winning and losing a game. Winning or losing a game is equally likely. You can win or you can even lose it. So all these are equally likely events. And you have one more, mutually so here these are like disjoint events, okay? When one happens, the other will never happen. Say when you tossing a coin, okay? You can take that as an example. Getting a head is equally likely. Getting a tail is also equally likely. But getting both is definitely not possible, right? Getting both the events together is not at all possible. So those events you call it as mutually exclusive events. Okay? So these are the basic things you should know in probability, and maybe in our next class we would do some direct problems related to probability. Till then, it's bye from Vasavi. Bye.